Hello everyone, welcome back to another video. So today we will be discussing a tutorial for weekly contest 388, and I was able to solve all four problems, so I will try to explain all four problems. So let's just move to first question. So in first question we are given two arrays as apple and capacity, and what we have to do is fill these apples in this capacity. Capacity is so there are m boxes and ith box has capacity of I. So these are five boxes and we can fill uh, at most capacity of 5 apples in each ith box, and we have to return minimum number of boxes you need to select, so we can fill all the apples from n packs. So here as you can see there are 3 packs, 1 3 2, and there are five boxes. So we can use two boxes of capacity 4 and 5 and fill all these apples such, because in first in box of capacity 5 we can fill this 3 and 2, and remaining one can be filled in this second box of capacity 4, and in this way we only took two boxes and there is no other answer which has a minimum there is no other minimum answer than 2. Similarly, in this answer here is 4 because we will need to use all the boxes. Now this is a very simple greedy problem. So what greedy, or you can say basic implementation, basically putting the apples here, let's say 1 3 2, we can represent this whole array as one sum only, because we need to distribute total number of 1 3 2 in 6 apples. Now we don't have any condition such that a pack a, the apples of a single pack only goes in single box with, so we don't have that condition. Basically we have to distribute the 6 apples in a capacity array, this array, such that number of minimum boxes are required. So you will always try to fill this apples in the box which has highest capacity. So if we have to fill 6 boxes, what is highest capacity? 5. So we will try to fill the 6 apples in box of capacity 5. Now if you fill this 5, remaining is 1 now, and for 1 again you will choose the second maximum because 5 is filled now. So remaining maximum capacity is 4, and you will fill that one, and so total number of boxes required is 2. So basically what you have to do is try to fill total number of apples in a box which has maximum capacity and not filled, and just count the number of boxes required. So let's just see the code. So I'm calculating the sum of first vector, and I just sorted the second vector and reverse it for, so I can get the maximum element first, and I haven't created a counter, and if I'm iterating over b now, so first element will always be maximum because I have sorted it at reverse the vector. So if current sum is, so whatever we require, whatever apples we have, if it is less than equal to capacity of box, we can just return cnt plus 1, and if it is current number of apples is greater than the capacity, we can just fill b of I apple from sum into ith box and increment the counter. And we are also given that it is always possible, so this will just all, there will be always a condition where we are returning in this array, so I'm just returning 0 for not getting compilation error here. And this was pretty simple question. So let's just move on to second question. Now in second question, what we are given is we are given an array of length n and a positive integer k. So there are n children standing into. So we have to choose k children such that uh, in k terms such that the happiness value of all children, whenever we choose a value, a children, the happiness value gets added in our answer, and all the other children which are not selected, the happiness value decreases by 1. And if it becomes 0, we cannot decrement it more. So we have to return maximum sum of happiness value of selected children. So this is another simulation question, but we need to just add an break statement for, because constraints of k here can be might give you daily, I don't know exactly, but you basically what you need is a breaking statement. So for, let's say for this, I can choose a child with first, in first operation I will choose the child which has maximum happiness, which is 3. Then I will choose 3, so 3 will added out into our answer. Then happiness decrements for all other, so 0 and 1. And now we will pick the child. So the maximum happiness we can pick is 1. Then our sum becomes 4, and as k is 0, we cannot make any more operations. So here answer is 4. Similarly here answer is 1, because we can only choose 1, and after that operation all of other happiness becomes 0. Similarly here I have k equal to 1 only, so I can choose only maximum happiness, which is 5, and that's the answer because only one operation is there. So this is again a simple implementation problem. I have declared an answer vector. I have sorted all the happiness array, and I have also declared a counter. So counter basically implies how many children, how many happy children are selected. So I'm iterating from last to first, and I'm this taking d as a of I minus cnt. So a of I is first happiness before the performing any operation, and minus cnt basically number of operations performed before this index. And if d is less than equal to 0, I just need to break, because I'm iterating from right side to left side. All the elements on the left will always be less than equal to current index, and if they are less than equal to current index, all the elements on left side will also be negative or equal to negative or 0, and that doesn't add any value to our answer. So we can just break there, and I will just add answer plus d if this doesn't break. Increment the count as we perform the operation, and decrease k, and if k also becomes 0, we have to break, and finally return answer. So as usual, simple implementation problem as normal second questions are. So let's just move on to third question. Now third question is again brute force type of question. So what we are given is array of size n, and we have to find an answer array of size n such that answer of I is shortest substring of array of I that does not occur as substring in any other string and array. So if there are multiple substrings, we have to return lexicographically smallest, and if no such substrings exist, answer of I should be an empty string. So what you can see here is we are given an array, and We have to find an answer for each index. So for first string CAB, the shortest substring that does not occur in any other string is either CA or AB, because in all the substrings which we can form CAB are, so all the substrings which can be formed in CAB are, first of length 1 is CAB, of length 2 is CA and AB, and of length 3 is CAB. Now this CAB also occurs in one of C occurs in this substring, in this string as a substring. A occurs in this both the strings as a substring, and B also occurs here in third string. So this cannot be our answer. Any one of the substring cannot be our answer. Now CA and AB doesn't occur in any other substring other than the string at 0th position, and we have to obviously choose lexicographically smaller string. So here lexicographically smaller string is A. So AB. So here answer is AB. Similarly, for second test case, there is second index. There is no such substring that does not occur in any other string. So here answer is just if there is no answer found, we have to just return empty substring. Similarly, in third case, we have BA, which is shortest substring, which does not occur in any of other string. So we have to return BA here. Same for C. There is no C always occurs in this C occurs in this CAB string. So here answer is, we cannot find an answer. So we have to return an empty string. Same case for this. And here if you see the constraints, n is 100 and array of I dot length is 20. So if you try to find all the possible substrings of any of the whole array, so the time complexity becomes uh, n is the size of vector array and L is length of each string. So according to constraints, it becomes 100 into 20 into 20, so which comes out to be uh, 40,000. So 4 into 10 raised to power 4. Now even if you add an so this is 4 into 10 raised to power 4. So what you can do is we can pre-compute all the occurrences of substrings previously, and then for each character again we will iterate over each index and try to find such substring which occurs only in that substring but not in other substring, and if there is any substring we will just take it as our answer. And there is additional condition of shortest and lexicographically smallest, so we can also handle that. There is no problem. So I think logic was pretty simple. So let's just see the code first. So I have declared a map of string and int, and I'm pre-computing all the substrings. So for pre-computing, I'm first writing loop of size n, and in each iteration I am writing a loop of a of I dot length into a of I dot length. So basically to find all the substrings of length a of I dot length. And how you can do it? So you can fix the starting point of the substring. For example, this can be 0 to a of I dot length, and uh, keep appending an element from that index to last index. So for example, AB we have a string, Now we will fix the starting position. Let's say we have fixed this starting position as I equal to 0. What substrings we can get? So we can get first A. So here first iteration I added A and mapped it with uh, incremented the frequency of that string. Now I will append second index, which is B. Similarly, I will append third index A. Similarly, AB. So this is how you calculate string. Count all the substrings in n square. A lot of people tried probably solve this with n cube length cube type of solution, where they have starting element, starting index, last index, then iterating over this to calculate string the substring itself. So it might also work because it will give a complexity of order 4 into 20, so 8 into 10 raised to power 5, which is I think acceptable in this question. So first I calculated all the substrings, then I declared a vector of size answer of size n, and initially all of them are empty strings. Now what I am doing is I am uh, removing all the occurrences of substrings of ith string. So here I am decrementing all of the substrings which are occurring in ith string. Now if I removed all the substrings of ith string, all the map mp of so now the number of occurrences of uh, all the such substrings which are occurring in ith string should be equal to 0. If it is not equal to 0, that means that substring is already present in other string as a substring in other strings except I. So if mp of s now here is 0, what I can do, if I can this s can be one of might be the answer for index I. So for that I have declared a string current, so which is just global answer till now. So if current dot length is 0, obviously if I don't find it, it is our first answer, I will just make current equal to x s. Now if s dot length is less than current dot length, because we have to obviously find minimum shortest substring, so I will just make current equal to s. And if it is not less but it is equal, then I can just check for lexicographical fault by just comparing s less than cur, and if we found this relation, we can just make cur equal to s. And finally I'm just re incrementing the occurrence of s because it might be used in other substrings. So again, this was pretty simple question but kind of brute force solution. So in this type of question you don't learn any new concept, you just try to write a better code. So this type of questions are not preferred. You can add more greedy type of questions, so that will make the contest very interesting. So now the fourth question, I think fourth question was a bit difficult according to these submissions. So in fourth question we are given an array of integer nums of length n, and also a positive integer odd integer which is k, and we have to basically choose x subarrays such that uh, for they have defined the strength of x subarrays as, so sum of all elements in first subarray into x minus sum of uh, all the elements in subarray 2 into x minus 1 plus sum of array sum of elements all elements in subarray 3 into x minus 2, then minus again plus. So you understand there is a pattern which can be represented as minus 1 raised to power I plus 1 into sum of I into x minus I plus 1 for all I in 1 to x. And what we need to do is we need to choose exactly k disjoint subarrays such that the strength is maximum, and we have to return the maximum possible strength that can be obtained. Let's just take an example for better understanding. So the first array is 1 2 3 minus 1 and minus 2. Now we have to choose 3 subarrays such that the strength is maximized. Now where the answer is maximum? So when we choose first subarray as 1 2 3, second subarray as only minus 1, and third subarray as only 2. Now if we the strength here becomes uh, first of all the sum of first subarray into 3 minus sum of second subarray minus 1 into 2, because this is uh, second subarray, and k minus 2 plus 1 here is 2, and for third subarray sum of subarray is 2 and k here is 1. So answer here is 18 plus 2 plus 2, so 22. Similarly, in second case we have to choose 5 exactly subarrays, so there is no option, just choose first element as first subarray, second as second, third and as third, and kill this till 5, and what we get here answer as is 64. And formula, if you don't understand, is 12 into 5 minus 2 into 4 minus 2 into 3 minus 2 into 2 and minus 2 into 1, but sign change as the subarray changes. So answer here is 64, and in this case k is equal to 1, so here answer is minus 1. So there can also be elements which do not participate in any subarray. For example, here minus 2 and minus 3 do not participate in any subarray, so here answer is just minus 1. So prerequisite of this question is you should be able to understand this is the question of recursion basically, and you have to optimize that recursion using DP. That's it. That's the prerequisite. If you don't understand this, so you are probably not familiar with either recursion or dynamic programming, or you have not solved similar type of questions. So basically this type of question is where you are choosing element at each position to take it or leave it, but this is building block of the whole question. So this is a pretty standard question where you can either take the current element or do not take the current element, but in this question there are additional conditions. So there are, I think, multiple possibilities which you need to handle, and they have also dropped some hints while uh, in the constraints, which makes more obvious that this is a recursive question. So here they are given n to k is less than equal to 10 raised to power 6. So what I thought was, obviously I have to use a 2D DP of n into k. So for each n I am iterating the index, and for each k I am iterating if the current element is a part of k any jth subarray where j is 1 to k. But while solving this, I also need to add another 0 to 1 boolean. So this makes the question of PDDP, and this 0 1 has a very important contribution to this uh, choice diagram for each element. And so I will just explain the code, and uh, yeah, this question is kind of hard to explain, but uh, basically what we have to do is we have to improve simplify this choice diagram based on this third third parameter which we are using. So this third parameter I am using is for two cases. If it is 0, that means subarray has not started. Kth or jth subarray has not started, and if it is 1, then jth subarray has already started. So previous element has already started the jth subarray. So that's why I am using this uh, boolean, and n for indexes and k for which subarray currently is going on. So this is obviously a recursive question, because writing an iterative approach for this iterative DP is difficult. So first of all, I am declaring an PDDP of size n plus 1, k plus 1 and 2, and I am making all of them as 1e15, because maximum answer can be 10 raised to power 13, because 10 raised to power 9 into 10 raised to power 4. So and here answer can be -1, so we cannot initialize the DP vector with -1. So what I did was I initialized it with 1e5, and currently ch is the third parameter, and we haven't started that subarray. So initially ch is 0, initially index is 0 in 0 based indexing, and 1 is we are working on first subarray. So in recursive function, uh, first I am there are base conditions. So these two are base conditions. So if counter becomes k plus 1, that means I have finished case making of k subarrays. I will just return 0, because my answer I have found the answer for where I am making k subarrays. Now I have declared a temporary minimum variable. So this always returns a very low value. So minus 1 is 15. So least answer here can be minus 10 raised to power 13. But if I return minus 10 raised to power 15, I get that I did not find any answer in this uh, choice diagram or tree. And if dp of I, cnt and ch is not equal to 1e5, I will just return it. Now basically cnt is number of current subarray which we are working, and if we have to find this function x minus I plus 1, so this will be equal to k minus cnt plus 1, and uh, this can be either minus or plus. So for that sign, if cnt percent is 2 equal to 0, so if you are working on second, fourth, sixth subarray, I need to multiply it by -1, and again for this step I am making answer equal to temp is a very low value, negative high value, so basically very minimum value, and I have two choices uh, based on this ch value. So if ch equal to 0, that means I have not started any subarray uh, till this index. Means I have completed some subarray, but this current index is not a part of any continuous subarray. So in that case, what I can do is I can start a new subarray. So if I start this new subarray, I have to add remaining into a of I into our answer and increment I plus 1 and keep cnt that same as it is, because the subarray is not ending at that position, and make ch equal to 1. That means I have started that subarray. In second example, second case can be I plus 1 plus but cnt plus 1, because I can just start the subarray at this position and end the subarray at this position only. So here ch will become 0 but counter will increase. And third is ignore the element. So I just do not take that element, make ch will remain 0, just increment the index, and no need to add this because we didn't take it as one of the part of subarray. Now if ch equal to 1, that means this current index is a part, can be a part of continuous subarray which has started before previous element, before or equal to previous element. So in that case I might have I have this option where I continue with the previous subarray. So I contribute that to that subarray, and the end is also not, I am not ending that subarray. I will it will continue further. Second option is cut that array uh, before it. So take the element and cut the subarray. So I will take that element, increment counter such that I have basically processed cnt plus cnt subarray and make ch equal to 0, because now new subarray is not started. And third is I do not take that element but break the subarray before it. So I have I broke break the subarray, increment the counter because the subarray is processed, and make ch equal to 0 but without adding this weighted sum of current element. So this can be, I think, minimized. I just wrote what I thought, but there are definitely some conditions which are overlapping, but this memoization will take care of that, and we will not get TLE or MLE. And finally, storing that answer in dp of I, cnt and ch, and just return. So if you understand recursion, there are obviously difficult conditions which you need to understand. So you need to understand this choice diagram, and uh, I got one wrong submission because of this only, because I have issues resolving each choice diagram. So I just wrote all the choice diagrams which are obviously overlapping, but we don't need to take care of that in such. So these constraints are not so tight, so we can just make some additional calls which are handled by this, but still take implicit stack memory to implement it. But still, so constraints were not tight, so I got accepted, and only 319 people solved it. I think this is, first of all, understanding this question is of recursion is first barrier. Second is resolving these conditions, and what kind of DP is this. If you see this constraint, you will understand this is a 2D DP of order 2D DP, but actually 3D DP, because we need an additional variable. And if you not able to solve it, it's okay. You just need more practice in writing uh, higher order recursive DP solutions like this. So I have seen 60 DP solutions also. So I was able to solve this. I think that's it from my side. Thank you for watching.